Okay, so let's take a look at this sample problem. So it says the essentials of a mass spectrometer, which can be used to measure the mass of an ion. 他说可以测量一个离子的一个质量啊，离子的质量 ，mass of an ion。就是它的意思是因为离子是带电荷啊，所以它能测一些带电荷的粒子。Okay, an ion mass m to be measured and charge q is produced in source S. Okay, so it is generated here. Okay, the initially stationary 是静止嘛。Stationary ion is accelerated by the electric field due to the potential difference V. Okay, so the potential difference is here, and there will be E field. Okay, and E field between here and there. Okay, so this E field accelerate the ion. Okay, so the ion leaves S and enters a separated chamber in which a uniform B field is perpendicular to the path of the ion. Okay, so this purple box is the chamber. Okay, inside it there is a uniform B field, and then it is out of the page. Indicated by these green dots. Okay, a white detector lines the bottom wall of the chamber and path of the ion. So a white detector lines the bottom wall of the chamber and the causes of the ion to move in a semicircle and thus strike the detector. Okay, so actually if a charged particle enters a perpendicular B field, okay, it will have a circular motion. Okay, so in that case, outside this purple box is there isn't any B field. Okay, so the path will be like a semicircle and then hit this detector. Okay, so the way to measure the mass is to measure the radius, okay, or the diameter of this semicircle. So based on the formula for the circular motion, we can be able to calculate the mass of the ion. Okay, suppose that BV have this value, ion of charge Q is this. Strike the detector at a point lies at X. X is from this hole to here. Okay, what is the mass m of the individual ions at in atomic mass unit? Okay, so 1 U is this kilogram. Okay, so this mass is actually the mass of a proton, or roughly a neutron. 就是一个质子的质量，它叫做一个 U. Okay, so here we summarize all the numbers here so that we can make use of it. So here we can have the conservation of mechanical energy, as there won't be any loss here. There won't be any other forces acting on it. Okay, except the Lorentz force acting on the charge inside this region. But as we know, for the circular motion, the speed of the particle doesn't change. Okay, it only changes the direction. So 就是圆周运动是匀速的嘛，它只是改变方向而已，它只是在圆上面每一点的速度的大小都一样。Okay. So actually we can assume the kinetic energy doesn't change at all. Okay, so actually, actually here what it really means is, here there is a potential. There is a potential energy here. There is a potential energy here. So starting from here, the particle is initially stationary or at rest, so there won't be any kinetic energy, and there are full of potential energy. So up to this point, all the potential energy transfer to the particles' kinetic energy. So we can have delta K will be 1/2 mv squared. Okay, starting from the at rest is 0, okay, becomes half of mv squared. And then the change of delta U will be minus QV, minus QV. Okay, this is plus Q, okay, so minus QV, okay, will be 0. So we have V equals square root of 2Q capital V and then over M. Over M. Okay, so we can just solve V in terms of other variables. Okay, so here is a circular motion, so we can make use of R equals mv over qb. Mv over qb. Okay, so here we have V, so that we can substitute here. So we have m over qb and then square root of 2qv over m. Okay, so we can actually putting this one inside become m square, putting this one inside become q square. So this q and q can cancel, this m and m can cancel. So it becomes 1 over b and then square root of 2m capital V and then over q, something like this. Okay, so here what we get is this x, this x is here. This x is actually 2r. This x is actually 2r. X equals 2r, so it is actually this one, okay, multiplied by 2 over b and then square root of 2mv over q. Okay, so we get all the, so actually what we like to solve is the mass of this ion, which means we like to solve this one. So we can take square on both sides and then try to solve for m. So finally we have m equals 8v. Okay, we have 2 square root of 2 and then square root of v. So the square will be 8v and then move it to the other side. And then we have we have x square. X square is here, and then b square moving to here. And then also we have a small q like this. Okay, now we can plug in all the numbers. So x is 1.6254 meter, and then times b is this one, 80 times 10 to the negative third quantity squared, and then times 1.6022 times 10 to the negative 9, and then all over 8v is 1000 volt. 1000 volt. Okay, so this is 3.3863 times 10 to negative 25 kilogram. Okay, and then what it asks is it likes you to represent this number in the atomic unit. Okay, so you can just divide this thing by 1.66 something, 1.6605 times 10 to the negative 27 kilogram. Okay, so it becomes U, okay, which is 203.93 U. Okay, so this is the answer. So which means the mass of this ion, is around 204 U. Okay, maybe this is an error. Okay, so it combines a combination of proton and the number of proton and the number of neutron. They adds up to be 204. Adds up to be 204. Okay, as the mass of an electron is very light. Okay, so the mass of an electron is 9.11 times 10 to negative 31. Okay, so it has a three order difference. Okay, 1,000 times difference, more than 1,000 times difference. So yeah, so you won't expect there are too much electrons there. Okay, yeah. So here we talk about another topic called the particle accelerator. 就是叫做粒子加速器啊，粒子加速器。Okay, so there are two types. One is called cyclotron, and the other one is called synchrotron. Okay, so here, the cyclotron, 中文叫做回旋加速器啊，回旋加速器。Okay, so as you can see here, okay, there's a spiral line. Okay, so the particle is actually accelerate like this. So there are quite a lot of text, but I think I just stop it here. I just skip it and I try to explain it how it works. Okay, so actually it start from the center. Okay, it start from the center. This is the source. S is the source. So how does it work? Okay, here we have two disks. We have two semicircle disks. 有两个半圆形的盘子吧，那大概是这种结构啊。And then we have a small gap in between. Okay, so here we have some function. Okay, between this region. Okay, but the idea here is like, okay, starting from the source. Okay, starting from the source is probably, okay, we will generate E field between this gap. We will generate E field. Okay, sometimes the E field points to the left side, sometimes the E field points to the right side. Alternatively, okay, alternatively, 就是它一半时间会向左，一半时间会向右啊，维持着这种状态。Okay, so starting from S, okay, so maybe if the particle is a positive charge, and then if at this moment the E field is pointing to the left side, okay, so there will be an acceleration, okay, pointing to the right side. So the particle will accelerate from here up to this point. Okay, it's the first point. Okay, so there will be an initial velocity, let's say v, okay, entering. Okay, so in these two disks there will be B field. Okay, there will be uniform B field inside these two disks, and then perpendicular to this plane. Okay, so in that case, charged particle entering a perpendicular B field or orthogonal B field. Okay, it will be circular motion. Okay, so the charge will move like this. Okay, move like this. So at this point v, okay, so after going to this point the velocity is still v. Okay, and in that case, in this region there won't be any B field. Okay, so after going to this point it will go straight to here. Okay, but at this moment we will change the E field pointing to the right side. Okay, so let's say I just try to draw that line in red. Okay, so like this. Okay, and in that case, I make the E field pointing to the right side. So in that case, this E field will accelerate this particle in this region. Okay, so at this point it becomes, let's say, V prime, which is larger than V, So in this case, okay, we have B field, B field. Okay, B field. Okay, so in that case, this V prime entering this orthogonal B field, okay, it becomes circular motion again. Okay, so at this point, V prime again. And then at this point, I switch the E field back to pointing to the left side. Okay, so it accelerates again. And then go into this point and then do another circular motion with a larger radius. So why the radius become larger and larger? So the idea is here. Okay, you can see the mass doesn't change, the charge doesn't change, and then the B doesn't change either. So what can be changed is only this V. Okay, so if V is larger, the radius is proportionally larger， 就是 R 跟 V 成正比的。所以我们就是在这个两个半圆形盘子的那个缝隙里面，让这个 E field 把它加速，就一直来回加速。那它每加速一次，它的半径就会增大，所以它的轨迹就会长这样。然后如果你要算的话，其实它在这边的时间跟在这边的时间是一样的啊，这边的时间，所以我们交换这个 E field 的时间就是一半的就可以。但有可能会越来越快，就是因为在这边的时间它会变快的，但是这边它慢，但是走的距离短，这边快了，但是走的距离也跟着变长，因为它们正比的，所以其实走这个半圆的时间跟走这个半圆的时间是一模一样的啊，因为 2 派 r 嘛，2 派 r， 然后 r 又跟 v 成正比，那你的 v 也成比例的增大，所以时间是那半圆的时间是一模一样的，但是走中间这里往左，这里往右的时间其实是会越来越短的。Okay, so this is the mechanism for the cyclotron. So there is a formula like this. Okay, so F or F oscillation. F oscillation means the frequency of the E field exchange. Okay, 就是这个 E field 的方向交换的速度或者是那个频率，就是这个 F. So this F is actually 2 pi m QB or QB over 2 pi m, which is actually 2 pi m actually this one 2 pi m over QB. How can we get this? Is to have this one. Okay, 2 pi r over 2 pi r equals Vt, and then we plug in r here so that we can get T to be 2 pi m over QB, which is here. So F times T is nothing but 1. Okay, so F will be the reciprocal of the the frequency will be the reciprocal of the period. So F will be QB over 2 pi m. Okay, so this is the frequency that we would like to switch the direction of the E field. Okay, so this is more or less the mechanism of the cyclotron. Okay, so here we have a limitation. So for this synchrotron, the energy is only up to 50 mega eV. Okay, it is not large. It is not large. Yeah, the idea is that, okay, we need to generate the B field inside this whole disk and also this half. Okay, so as much as you need to generate B field, you need to spend power. You need to spend power. Okay, so generating large B field inside these two disks is not, yeah, you need quite a lot of power to do so. So this is the limitation. This is the limitation. Okay, so yeah. So if you're interested, you can see, okay, how fast, okay, is related to this this energy. Okay. Okay, so rather than the cyclotron, we have another one called the synchrotron. We don't try to explain too much, but the idea is to have a structure like this. Okay, so the synchrotron becomes a ring. Okay, so the locus of the particles is always inside this ring. Okay, so what you really need to do is to control the B field. Control the B field. Okay, so you need a more complex controlling circuit so that the particle can accelerate inside this ring. Okay, and in that case, you only need to generate B field in this ring rather than a whole circle, so that the power can be more concentrated here, so you can generate a larger B field for a higher speed. Okay, so we don't try to go too deep, but yeah, the idea is like the proton follow a circular, not a spiral. For the previous case is a spiral. The radius become larger and larger. So here the magnet need extend only along a circular path, not cover some yeah. For the previous case, the radius is or the area is this large. Okay, 就是4乘以10的6次方平方米这么大的一个加速器，一个加速器。所以如果你看过一些物理的新闻，那些粒子加速器的话是要挖地道，然后做一个什么多少公里的一个轨道给它去加速。Okay, so the circular path, however, still must be large if high energies are to be achieved. Okay, so if you're interested, you can check it out on the Wikipedia about the proton synchrotron. So the beam is then inject to a proton synchrotron booster, 就是 proton synchrotron 的前一级叫做 booster， 就是它很慢，然后后面很快，所以我们中间加一级给它让它从很慢变成中级再进入到这个很快的地方。So which accelerate the proton to 1.4 gigahertz. So PSB, okay, accelerate the particle up to 1.4 gigaeV, followed by the proton synchrotron, which push the beam to 25 gigaeV, 25 gigaeV. Okay, so comparing with this one of 50 mega eV is much smaller. OK， 那加速到这么快有什么用？有什么用？你还记得第21章我们讲过一个叫做Standard Model of Elementary Particles 还记得的话，这个就比如说左边这些夸克lepton。这里就每一个的左上角其实是有个能量的那其实就是我们要得到它的话，大概需要那么多的能量的大小那第一阶的话比较容易得到是 mega eV level 的这些就已经需要到 几十 m 或者是1.2 G 个 eV 啦，那在这里更大。有没有第四级不知道啊，但是假如说真的有第四级的话，那就需要更大的能量去加速这些粒子啊，去加速这些粒子才能得到哦。因为怎么说，就是这个所谓的 Standard Model of Elementary Particle， 它做这个的意义是说，这个世界万物所有的东西，我把它拆开哦，一路拆到最小之后，它现在能发现的就是有这些夸克，有这些 leptons， 有些 lepton 就是氢子嘛，氢子，或者有一些叫做boson boson 对 boson 玻色子有这些东西，但是这些东西其实只包括我们这个宇宙里面的质量不到10%，好像5%左右的啊，所以就是有95%的东西我还不知道，所以他们会提出一些叫做暗物质或者暗能量的东西啊，就是一些还不知道的东西啊，所以就是说要怎么得到，就是好像说你有一个手机啊，你如果要拆开它一个零件拆出来的话，那你就拿个工具慢慢把它拆个几小时拆出来，或者拿什么工具的话快一些。那最快的方式的话，就是你一手拿起来，一下就砸在地上，它就会炸开。那这是最快可以炸出一些新的东西的一个方式。所以他们也是说，我们把粒子加速的很快，让他们去碰撞啊，他们就有机会把它撞散啊，就是那种感觉啊，对，所以这个世界上它就在研发这种加速器，就是为什么要 push 这种能量，就是这个目的，就是你看到这个几十个 G 个 eV， 它就是大概能够找到那类似的例子。Okay, so here for sample problem, so it says suppose a synchrotron is operated at an oscillation frequency of 12 megahertz and has a d radius r. Okay, what is the magnitude of the B field need for deuteratron? Okay, deuteratron means one proton and one neutron. Okay, 所以它像是一个氢原子多了一个中子的感觉，当然它这里就没有那个电子在内，它只有一个质子，一个中子 ，OK，but to be accelerated in the synchrotron， OK， 因为如果它有电子的话，它中性的话，它又加速不了 ，OK， 所以它就只有一个正电荷，但是有两个质子的质量，因为中子质量差不多。So the deuteratron mass is this one, okay, so roughly 2 times of the mass of a proton. Okay, so B will be 2 pi m and then F oscillation over absolute value of Q. Okay, so how do we get this? It's actually this one. Okay, so we slightly move around the terms, okay, because we would like to find B, okay, so which means we would like to keep B on one side and then move all the other variable to the other side. So we have 2 pi m F over Q. Okay, so here we can plug in all the numbers. 2 pi times 3.34 times 10 to negative 27. And then times 12 times 10 to the 6th power over 1.6 times 10 to minus 19. So this is 1.57 Tesla. Okay, so this is for question A. Right. What is the magnitude of the B field? Okay, so this is the magnitude of the B field. Okay, so this is pretty easy. You just need to plug in all the numbers. So for question B, what is the resulting kinetic energy of the deuterons? So V will be RQB over M. Okay, so this is nothing but the radius for the circular motion. We just move around the terms. So we have 0.53, 53 centimeter, and then times 1.6 times 10 to minus 19, and then times 1.57. We just calculate in the previous question. So 3.34 times 10 to negative 27. So this is 3.99 times 10 to the 7th power meter per second. Okay, so this is pretty fast. Around 1/10 of more than 1/10 of the speed of light. Okay. The speed of light is roughly 2.998 times 10 to the 8th power meter per second. Okay, so this is the speed of light. The speed of light. So this is more than a tenth of it. So in that case, we probably need to consider the relativity effect， 就是这个速度的话，其实我们要考虑一些相对论的效应。如果你只是单纯用一个古典力学的公式去算它中间一些效应的话，就会误差会蛮大的。虽然这里我们还是用这个 k 等于1/2mv平方，那在相对论里面的话，它 k 会等于这个伽马减 1mc 平方的，会是这个，但是这个是37章的内容37还是38章的内容，我忘记了，37啊。这个是狭义相对论的东西。Okay, so this is actually 1/2 and then 3.34 times 10 to negative 27 times 3.99 times 10 to the 7th power squared. So this is 2.7 times 10 to negative 12 joule. Okay, so if we divide this number by 1.6 times 10 to minus 19, so this will be 17. Okay, 17 mega EV. 17 mega EV. So this is less than 50 mega EV. Just So this number. So in all the I mean for most of the question in the textbook, so the numbers has its meaning. You cannot try to adjust it too much, okay? Because this number will be like a practical values. 就是当然，如果你单纯你把那些公式当做一个数学式子，你带什么数字都可以，但是你要让它有物理存在的意义的话，其实课本大部分那些题目给出的数字是相对比较真实的数值，它算出来的东西跟实际的就会差不多，或者甚至是一样。Okay, so here we talk about the magnetic force on a current carrying wire. Okay, so I will consider it is another form of the Lorentz force. Okay, it is still the Lorentz force. Okay, you can easily see why I like to say it like this. Okay, so here it says a straight wire carrying a current I in a uniform B field experience a sideways force. OK， 所以它的意思是说，现在我们有一根导线，就是两头是绑着的，然后我们这里去放一个垂直的，就是产生一个垂直的 B field，如果没有电流的话，就除了重力之外，就没有力作用在它上面。如果有电流的话，它就会有一个侧向力就比如说电流往上的话，这个力往右这个电流往下的话，这个力往左就是有一个侧向力 sideway force. Okay, so this force is actually IF, I mean FB equals I L cross B, L cross B. So yeah, so I would say that this is another form of FB equals Q V cross B. Okay, at least you can see that this is a cross here. We have something like this. I and Q should be related. Okay, and then yeah, L and V, and then okay, this B is the same. Okay, so here let's take a look at here. So let me explain why the direction of the force is like this. So so here for this I, we assume we have positive charge moving upward. Okay, so of course we know this it should be negative charge moving downwards, but in this case, if we assume the positive charge moving upward and negative charge moving downwards will be the same. Okay, so only as I know, only the Hall effect will have issue, but most of other case they won't be issue. That's why at that moment most of the physicians don't know whether the moving carrier are positive charge or negative charge. Okay, so here we just assume we have positive charge moving upward. So in that case, it is like positive charge moving in a perpendicular, orthogonal B view. Okay, so in this case, V is pointing upward, B is pointing out of the page, so we can use right hand rule. Okay, we use our right hand, okay, pointing upward and then cross to out of the page. So our thumb is pointing to the right side. So that's why this is the direction of V cross B, and which is the direction of FB. Okay, so that's why there's a sideways force acting on the wire to the right side. So simply you can clearly imagine that. Okay, so if we have a positive charge Q moving downward, so this is V is also pointing downward. So you use your forefinger pointing to the downside and then cross it out of the page. Your thumb will pointing to the left side. So that's why we will have FB pointing to the left side. So I would say this is actually the Lorentz force. Oh, but the form it appears is like we have a current in a wire, and then we put this wire perpendicular to a B field. So this B field will generate a Lorentz force acting on the current carrying wire. Okay. And actually, we can somehow see that why it will be like that. So for the DQ, okay, so maybe we can just put it like we put D and D here, DF and DQ. Okay, so in that case, we have a DQ dt, and then we have a V times dt. Okay, so we have divide one and then we multiply one again, so that these two dt cancel each other. So we have a dq over, or maybe I put it like this. I divide one vt and then we multiply one vt. Okay, so and then it cross with the B field. Okay, so in this case, this one is I V times dt should be L. Okay， 速度乘时间就是长度了嘛。and then it should be B. It should be B, or maybe yeah, like this. Okay, so here what we need to care about is the direction of the L. The direction of the L actually follows the direction of the conventional current, which means if here the current is going upward, so we consider the L is pointing upward. Okay, for for the part C or figure C, L is pointing downward. Okay, follow the direction of the current. So in that case, we have L cross B. L cross B is pointing to the right side. Okay, for this one, and then L cross B is pointing to the left side. So this is the only thing we need to pay attention. Okay, like this. Okay, so it also mentioned that if the wire is not straight, okay, so or the field is not uniform, then you need to cut the wire into many segments, or cut it into many segments. For each segment, DL, you calculate the DFB to be IDL cross B, and then you add all of them together. Okay, so you try to have a FB to be FB to be integration of DFB to be integration of IDL cross B. Okay, so it depends on whether this one is non-uniform or whether this one is not a straight line. So you need to use integration to calculate it if something in it is not uniform. Okay, so here we have a sample problem. Yeah. Okay. So this one is easy. So let me finish it. So here, a straight horizontal length of copper wire has a current I through it. Okay, so this one, okay, 就是水平的一根铜线。Okay, what are the magnitude and direction of the minimum B field need to suspend the wire that is to balance the gravitational force on it? Okay, 所以它就是有一个质量。Okay, so the linear density of the wire is 46.6 gram per meter. 所以这个线就会有一个重力嘛，因为它有一个重量嘛，所以它有重力。所以的话，然后现在也有一个 B field 在外面有一个 B field 在，然后他就问它有一个电流，是往外的往外的 out of the page 的，所以他就问我们要放一个多大的 B field 让这个洛伦兹力跟这个重力完全抵消。Okay, so here we have a ILB. ILB is actually the Lorentz force or the force acting on the carrying wire in the B field equals mg. Okay, so B equals mg over IL. Okay, mg over IL. So actually we don't have the number of the mass. Okay, what we have is the linear density, which means what we have is m over L. M over L is what we know. Okay, so this is mass per unit length. Okay, so this is G and then over I. So this is 46.6 gram per meter. So this is 10 times 10 to negative third power times 9.8 over I is 28. So the B field should be 1.6 times 10 to negative 2 Tesla.